Hello guys, welcome once again to another tutorial session in bioinformatics. In today's video, I am going to show you how you can generate phylogenetic trees using raxml. By the end of this tutorial, you would have generated this cool phylogenetic tree using raxml. Now, raxml is a tool that is used to estimate maximum likelihood phylogenies from DNA and protein sequences. And the installation is pretty simple and straightforward. You need to first download the source code, compile the code, and set the part of the binary file that has been generated after compilation. You can also install using Anaconda, and I have video tutorials that will show you how to install raxml. Link is in the description box below. Now, for this tutorial, you need to have this requirement satisfied. You need to have a PC that runs Linux, Windows, or macOS. This tutorial uses Linux, by the way, but the instructions should work on Windows and macOS as well. You need to have raxml installed on your PC. And by following the video tutorial in the previous slide, you'll be able to install it successfully and reproduce this video. You also need to have an internet browser. This will be used to access the iTOL server to render the tree to an image. Finally, you need to have the input data. This will be a sequence alignment file. I've already prepared that, and I'll provide you with a download link. It will be in the description box as well. Now that we are done with the introductions, let the analysis begin. We are going to first download the data. The data is going to be in the phylip format, and it's on my GitHub page. And this is a page. I'm going to leave the link to this page in the description box so that you can download the data. So I'm going to download this data here. This is the file, the phylip format. Okay. So to download, I just click it. Then go to raw. Click on raw. Then on this page, I'll right click and then select save page as. I'll save it on my desktop with the same name. That's ipob.refined.phylip. I save it. Now data has been downloaded. Let's check it out. So there's the data, and there it is on my desktop. So now we are going to move to the command line and then continue from there. On the command line, I'll first cd my home directory. I'll cd to my home directory. I am then going to explore my data. So let me check it out. I'll first do an ls. The data set is on my desktop. So this is my desktop. So I'll now list the content of it as well. So I'll say ls desktop. So there is the file. Now let's check the raxml executable file. If you follow the tutorial I showed, then it should be in your apps directory. Okay, so if I do an ls apps, raxml is going to be there. Okay, assuming that you compiled the same file as I showed in the video, then that's how it is. You can also compile other versions, but it's all fine. It will work out for you as well. Let's test raxml. Okay, so everything is working fine for us. Now it's time to run raxml on the alignment file. There's the alignment file. So let's run it. Let me clear the screen first. So this is how we do it. We say raxml HPC. Then you specify the input file, which is -s. Input file is on my desktop, so I say desktop/rp ob.refine.phylip. This is the file. This alignment file was generated using Muscle, so you take note of that. We also indicate -n. -n, you supply a name. This name will be given in addition to other names that raxml will use when other files have been produced. So you take note of that as well. So I repeat, the -n will give a name that will cut across all the files generated. Okay, so let's say raxml trees. Let's just use this name to make it simple. Now we specify model -m gtrcat. Now there are several models that I can choose for. Some have been provided for DNA sequences, others are for proteins. So you need to know what type of sequence you are dealing with and select the appropriate model. We are dealing with a DNA sequence, and that's why we are using this, because this is one of the models that can be used for DNA sequences. I'm also going to leave the link to the raxml page so they can read more about it. Now, raxml uses the maximum likelihood algorithm, and it also does random sampling and bootstrapping. So the next options here will be used for the bootstrapping options. The first one is -fa. This tells raxml to do a rapid bootstrapping. Now bootstrapping will require some initial random values. And those numbers are called seed numbers. Okay, so we specify with -x. Let's give it a number 1, 2, 3. And then -p. Let's say 2, 5, 6. Okay, so these flags here will provide random seed numbers that raxml will generate for the bootstrapping activity. Aside this, we also specify the number of replicates, which is -N. We want to make it automatic, so we say auto MRE. Because we compile the pthreads SSE3 version, we can also specify the number of threads raxml should use, and that will be done using the -T flag. So let's give it 4 processes. So now we can run raxml. So it's doing its work. Now it's complete. Okay. And these are some of the activities. It says found one tree, found this, that. Okay. Now let's clear the screen first and then check the files generated. So we say ls, and these are the files that were generated for us. Now the trees that has been generated are in the Newark format. Okay, so you take note of that. Some of the trees will give you the best trees with branch supports. Okay, I mean branch supports values. Okay, but in general, the tree you use here will depend on what you need for your analysis. If you need, let's say, the tree that has support values for branch and not only branch lengths, then you need to know which ones to use. Okay, now the full explanation of this particular trees, all of them are given in the raxml page, so I will leave that link so that you can quickly read on it and then understand them. For this tutorial, what we are going to use is the raxml bipartitions.raxml trees. That's what we are going to need. And we are using this tree because it provides support values. Okay, support values are values that tells how confident raxml is in separating some sequences of interest. The next stage is now to render the tree with this file into an image, and we are going to use the iTOL server. So let's go to the iTOL web page and then make it happen. So this is the file. I made a copy on my desktop, and that's what we are going to use on the server. So let's go to iTOL and then proceed from there. There's the iTOL page. So there's the iTOL page. Okay, I'm going to leave a link to this page in the description box as well, so that you can use that. So on the iTOL page, there are a lot of functionalities, but we are interested in the image rendering. Okay, so I'll upload. You can use this or this. Let's use this to upload. So you click on upload a tree, and then on the next page you browse for your file. So let's browse it. It's on my desktop. There's a file, so I'll open it and then I'll upload. So we wait for the tree to be uploaded for us. So there we have it. So on the iTOL page, we can manipulate this to get the image that we want. Notice the dashed lines for the branch here and here and here. So to disable these dashed lines, you can just go to branch length here and then click on ignore, and to give it to us like that. You can also change this tree to circular by clicking the circular one here, and to give it to us in circular. Okay, let's go back to rectangular. You can also increase the line width by coming to line style and then increasing it here. That can also be done. You can also do some additional annotations, but I'll leave that for you to explore. Okay, now let's look at the image itself and then look at how we are going to interpret it. Okay, so with the phylogenetic trees, the horizontal lines are branches. They indicate the amount of genetic change over time. Okay, so what happens is the longer the branch length, the greater the genetic change. That's what it means. Now for this tutorial, we are going to focus on the similarity of the sequences. We want to infer how similar they are. And so raxml uses support values to help us do that. So when you hover the mouse on the nodes, we have bootstrap values coming. That's the support values. raxml gives it to us from 0 to 100. Okay, some tools also give it from 0 to 1, but it doesn't matter anyway. Okay, so let's look at this first one here. When you have a higher bootstrap value, that indicates that raxml is highly confident the sequences are clearly different from others that you are comparing to. So looking at this node here, we have this clade here. Okay, and this support value of 100 tells us that the sequences here are clearly different from the sequences here and then here as well. Okay, so with phylogenetic trees, you can use it to check how similar some sequences are and also track the evolutionary history of that. We are going to do more of this particular analysis in later videos. But for now, just know that based on the support values given here, these sequences are clearly different from the sequences and then here as well. Okay, this one is very, very low. Okay, this one is 99, which is also high, indicating that raxml is confident that this group of sequences here is clearly different from the R50 one here. Okay, so that'll be all for this tutorial. And before I go, let me also show you how you can download this particular image to your local file. To download the images, you go to exports, click on it, and then here you can select the format you want, SVG or PDF or PNG. Okay, you can select any of them. So let's select the first one. Let's say PDF. You select on it. You can use screen or full image. Let me select full image. Then you go to export. Click on it. That's the green button. So it will render and then download it for you. So let's just wait for it. So you will then be asked to save it. I check save and then I save it. I'll save it on my desktop. You can also download in PNG formats. So you click on it and then you click export or you select which of the export area you want. Okay, now I've done that and then I'll be asked to download it. Let's save that one as well. You can also download the SVG graphics formats, which I prefer because I can always do some editing later. So I'll click export and then save it as well on my desktop. So now when you go to your download location, you have all these files there. This is a PDF. You can open. There's a PNG. You can also open here. I think this has a transparent background. You can also use the SVG here. You need to open with tools such as Inkscape that can open vector graphics. I already have one, so I can just open that one here. So this Inkscape. So when you have Inkscape and you open, you can edit this image here by changing the text here, by moving things around. That's what I'm doing. Or you can even change the color of the tree. Okay, the branches, you can change it with colors such as this one. Notice how this one has changed. Okay, so you can do a lot of manipulations, change text color, or add some additional information here. So that's why I prefer to use the SVG format, so that I have the flexibility of modifying them, especially if I'm going to do presentation or maybe publications. Okay, so this is how we do it with the SVG format as well. So I'll once again thank you for watching this video, and I'll see you in the next session. Goodbye.